All right, hello Precalculus, let's do this. Game plan for today is to learn about piecewise functions. So take a second and have this down, and we'll go over the idea of a piecewise function, right? So let's assume you have this, and we have this part here. Before we actually take a look at a piecewise function, let me show us this. So let's say if we just had some regular function like f of x equals 3x squared plus 5, right? And if I said, hey, what is f of 4? How would we evaluate what f of 4 is, right? What would you do? Anywhere you see x, we're going to plug in 4, right? So we just say 3 parentheses. We're going to plug the 4 in for x squared plus 5, right? And then, how would you continue? If you say 3 times 4, my heart will break, right? We don't do 3 times 4 first, right? First, we need to do the 4 squared first, right? So it's going to be 3 times 16 plus 5. And what is 3 times 16? That is, 48 plus 5. So that is 53. And visually, what does it mean? Well, what does this graph of 3x squared plus 5 look like, right? If I go plus 5 here, the graph looks something like this, right? That's the graph because we have some x squared. And visually, what does it mean? It means that when x is 4, the y value will be, over here in Carajo land, right? It'll be 53. Okay, and yeah, that's the idea of just a regular function. What's the domain of this function here? I could use any value in between negative infinity and positive infinity. No matter which number I use between negative infinity and positive infinity, I'm going to plug it into 3x squared plus 5. So let's take a look at what a piecewise function implies. So let me get this. Let's take a look at this. Here, for a piecewise function, it is a function defined by multiple subfunctions. So the idea is, if we take a look at the domain of this function, what it's stating is, in your own words, or take a second and pause the video, what do you think it means in your own words? Like for this part here, for x squared plus 4, how would you translate that? For x cubed minus 3, how do I translate this? And for the absolute value of 2x plus 5, how would I translate this, right? So here, if x, let me move this a little bit here. If we look at the first line, if x is less than or equal to negative 4, then we're going to use x squared minus 4. What about for the next part? If x is greater than negative 4 but less than 10, we're going to use x cubed minus 3. And the final part, let me take this out over here. And the final part, if x is greater than or equal to 10, then we're going to use 2x plus 5. So let's see, what on earth are we talking about here? Let's look at some examples. So notice that the name of this function is called g. And for different values of g, we're going to use the different sub-functions within g. So let's take a look at the first example, right? Like let's say if I have this over here, this is our g graph. Let me make sure my angle is good. And let's say if we wanted to find what is g of negative 7. Notice that this value of negative 7, for which part of the piecewise function would I plug in negative 7? Notice negative 7 is less than negative 4, right? So I'm going to plug in negative 7 to this part of the piecewise function. I'm not going to plug in negative 7 into here or here. So just all you would do is normally you just plug it in. So if I'm using x squared plus 4, then anywhere I see x, I'm just going to plug in negative 7 squared plus 4. And what is negative 7 squared plus 4? Pause the video if you want and try it on your own, but it should just be positive 49 plus 4, which is 53. Okay? So notice that when we plugged in negative 7, we plugged it into this part of the piecewise function because -7 is less than -4. Okay? What about for this one? What about g of -4? Where would I plug in -4 into which one of the functions, right? I'm sorry, which part of the subfunction? Notice that -4 would still go to this part of the function because what this is stating, it's saying that for any value, if x is less than or equal to -4, then we're going to plug it in here. So notice for this part, we still have to plug it into the top function here. So same idea, I still have x squared plus 4, and then I plug in my -4 squared plus 4. What is -4 squared? That is 16 plus 4, and that is 20, right? Not too bad, right? So what about the next part? If I have g of 2. If I have the x value of 2, which one of these functions would I plug 2 into? It would be for this one, for x cubed minus 3, because this is stating that if you have a value of x that is less than 10 or greater than -4, any number within this domain, we're going to plug in into this one. So here, so this just becomes, we're going to use the x cubed minus 3. So then this is just 2 cubed minus 3. And just be patient. What is 2 cubed, right? If you say 6, that breaks my heart. It's not 2 times 3, right? It's 2 times 2 times 2, which is 2 times 2 is 4. 4 times 2 is 8, right? So then this is 8 minus 3, which is just 5. Final part. Here, if I have g of 10, where would I plug in 10? Right? Pause the video and try it on your own. Right? I would plug in 10, not to the x cubed minus 3, because here notice that within this parameter, this part of the domain, 10 is not included. Neither is -4. But you have everything in between 10 and -4. Notice that if x is 10 or greater than 10, then we're going to use the absolute value of 2x plus 5, and we're going to plug in 10 in here. So then this just becomes absolute value 2 times 10 plus 5, which is absolute value of 20 plus 5, which is absolute value 25, which is, what is the absolute value of 25? It is 25. And yeah, that's just the general idea of a piecewise function. You're creating a function into multiple subfunctions, and you're assigning a certain part of the domain or parameter of where you're going to plug in your x values. Great. Now, that was pretty easy, or not too bad. The tricky part is, what about the graph? How would the graph of this look like? All right, so notice, let's break it down into 3 parts. So here, the first part is stating that for x is less than or equal to -4, we're going to use x squared. Wait, sorry, let me organize something. Okay, yeah. Here, notice if I have x is less than or -4, I'm sorry, if x is less than or equal to -4, if this is -4, let's make like a little boundary or like a little fence or something. What this is stating that x squared plus 4 lives here, right? And then what happens to everything between -4 and +10? Notice that which part of the subfunction, right? X cubed minus 3 lives here. And everything to the right side of 10, this absolute value of 2x plus 5 lives here, okay? So now here we just have to be a little bit patient and recall, let's take a look at this. If I said, hey, what does this graph of x squared plus 4 look like? If you really want, pause the video and try and think about it. What does this graph look like? What does this graph look like? And what does this graph look like? Right? X squared plus 4 should look something like this, right? This is x squared plus 4. What does x cubed minus 3 look like? I go 3 down and I go like that. That is x cubed, right? And absolute value of 2x plus 5 looks something like a v, right? We went over the visuals of these parent functions. So basically the idea is if this is negative 4, right? Negative 4 is somewhere here. It's like you're cutting this part of the graph, right? This part of the graph, you're cutting it and you're putting it over here. Right? If I have x is negative 4 over here, it's like you're cutting this part of the graph and putting it here. If I have x cubed minus 3, so like if this is negative 4 is somewhere here and positive 10 is somewhere here, it's like you're cutting this part of the graph and you're putting it here. And then for the absolute value of 2x plus 5, it's like we're cutting, this is like positive 10 is over here, we're cutting this part of the graph and putting it here. Okay? Now, to be precise of exactly where the points are, it's not too bad to figure out, and we kind of already did the work. Like here, let's start from left to right. Here, we know that everything less than negative 4, this x squared plus 4 lives. So if x is equal to negative 4, what is the y value when x is equal to negative 4? Notice we already did that, right? When we found g of negative 4, what was the y value of negative 4? It was 20. So notice that what you're going to do is, when x is negative 4, you go up to let's say this is 20, right? And notice that this will be the circle that we draw at first, and then ask yourself, is this open or closed, right? Open or closed circle. And notice that because you have the equal than, you have less than or equal to, this circle will be closed. And notice how, like when I look back at the x squared plus 4, right? Notice you're cutting this part of the graph, right? Because if the graph looks something like this, you're cutting this part over here, and then you know the graph has to look something like this. Because that's what x squared looks like. It looks like this part of the graph from the left side of the origin. Okay? Now we need to go, so this part we're good. Now let's focus on this part. Here, this is saying x cubed minus 3. So notice that when x is negative 4, the y value is here. But what happens when x is negative 4 for this part of the graph? So let's just look at this for a second. What happens if I plug in, wait, let me get some paper. Let's say I have x cubed minus 3, right? And I'm going to plug in negative 4 in here. Even though you're not really allowed to do that, right? We're just going to see where it will be. So let's say if I plug in negative 4 cubed minus 3, what is negative 4 cubed? This is negative 4 cubed will be negative 4 times negative 4 times negative 4, right? So negative 4 times negative 4 is positive 16 times negative 4 is negative 64. So notice that if x is negative 4 and you were to plug it in here, it goes to the y value of negative 64. So where would that part of the graph be? It would be, you know, somewhere here. This is negative, oh, whoops, sorry, what did we forget to do? Oh, we forgot to do, my bad. We're supposed to do negative 64 minus 3, so that should be negative 67, my bad. So yeah, it should be negative 67. So where is negative 67? Let's say it's somewhere down here. And notice we're still at x equals negative 4, so notice that if this is the line or the boundary, we're gonna have a circle here, and the question is open or closed. Notice that this part of the graph is open because you don't have negative 4. Even though it'll go here, at this part of the graph, when x is negative 4, it actually goes up here, so we have a closed circle here. And yeah, and the idea is, okay, so from this side, it's over here. What about everything in between? Well, we looked at everything in between, right? Because if this is the x cubed minus 3 graph, and this is the graph of x cubed, right? So we're going to try and cut and paste this. Notice that this part over here was that y value of negative 67. Now we need to find this part over here when it's at that x value of 10. So here, if we have 10, notice that when I plug in 10 into the function, it goes to the 2x plus 5, but let's see where it would go if it was at x cubed minus 3. So let's plug in 10. If I were to plug in 10 for x cubed minus 3 for, let's say, I'm going to plug in 10, right? So this is going to be 10 cubed minus 3. What is 10 cubed? That's 10 times 10 times 10. 10 times 10 is 100. Times another 10, that's 1,000. And then we're going to subtract 3, right? 1,000 minus 3 is 997. Okay, so then that means from here to when x is 10, this y value is somewhere, okay, let's say 997 is somewhere here, right? It would be here, but notice, is this part open or closed? This part is open, right? And then how does the graph look like? Well, what do we know about an x cubed minus, what do we know about what an x cubed minus 3 graph looks like? Well, this is negative 3, and the idea is it looks something like this. Like that. So this is that graph. You see how it's, right, for an x cubed it goes like this and then like that. So then this part of the graph goes all the way up to 997, and this part goes all the way down to negative 67. Notice it's open and open, and notice we have the center part. Final part, we have absolute value of 2x plus 5. What would I do here? Notice when I plug in positive 10, what did we get when we plugged in positive 10? Did we do that? I think we did. Wait, let me organize my papers. Yeah, we did. Notice that when we plugged in positive 10 before, the 2x, absolute value 2x plus 5, we got positive 25. So this y value of 25, notice that it's this part here, it's closed. And what does absolute value of 2x plus 5 look like? It looks like this V shape. And notice we're cutting this part of the graph to this right side here, so you know the graph should look something like that. And that's what this graph would look like. Whether it's beautiful or not, I leave it up to your imagination, but hopefully we understand, or the algebra we needed to do to see what the graph would look like makes sense. What I'll do is I'll give a delta math that will help you try to graph certain functions, because I think the part with evaluating functions is not that bad, right? You just have to look at the domain. Graphing it is a little bit tricky, and we'll try and practice some in class. All right, I hope you enjoyed the lesson. I'll put a delta math that gives nice questions where you're evaluating, and I think the graphing part might be a little tricky. We'll see how it goes, and then we'll go over it in class together. Hope you enjoyed.